They said northern Europe could grow warmer forever, that the Gulf Stream would keep its shores safe from harsh winters. Yet here we stand today, on the brink of an icy dilemma that could turn those predictions upside down. Does that sound impossible? Well, brace yourself, because scientists studying a colossal network of ocean currents in the Atlantic have uncovered signs that this vital circulation might be limping toward a dangerous tipping point. Today, we unravel the mysteries of these currents, known as the Atlantic Meridional Overturning Circulation, and ask one burning question. Could this be the calm before the biggest climate storm of our century? In this telling, we will journey into the frigid heart of the Greenland Sea, confront the surprising role of melting sea ice, and discuss why an implosion of these deep-water conveyors could transform entire continents in ways we barely dare to imagine. Picture the Arctic, 800 kilometers north of the fabled Arctic Circle. The region is awash in gentle purples at dawn and midnight blues at midday, a frozen seascape brimming with secrets. There, on a winter expedition across jagged fields of ice, the Norwegian research vessel Kronprins Haakon sets out to probe the heart of one of Earth's most puzzling phenomena. Its mission: to gather data that might help us glimpse the future of our global climate. For some, the mere mention of climate meltdown conjures visions of unstoppable tragedy, but for the team on deck, peering through the swirling snow, the stakes are nothing short of civilization-altering. If the Atlantic Meridional Overturning Circulation takes a rapid downturn, decades of climatological assumptions could spiral into chaos. But why does that matter for the rest of the world? Simply put, the Atlantic Meridional Overturning Circulation, while a mouthful to pronounce, might just be the single most influential oceanic power line on the planet. At the surface, it draws warm water from the balmy tropics all the way to northern latitudes. This global heat highway is part of why some lands far north of the equator enjoy comparatively mild winters and thriving fisheries. If that surface warmth fails to arrive in the quantities we've grown accustomed to, everything from seasonal weather patterns to agricultural cycles could shift in ways that feel like stepping into an alternate reality. Yet ironically, the warming climate is fueling a meltdown of sea ice and glaciers, flooding the ocean with fresh water that makes these currents less dense and potentially less able to sink and drive the crucial conveyor belt of heat. How fragile is this system, and what data are experts scrambling to collect before it's too late? We'll uncover exactly that by descending into the story of the Kronprins Haakon's voyage. In this episode, we'll track how researchers brave temperatures sinking below -30 degrees Celsius, focusing their instruments on the icy expanses of the Greenland Sea, searching for cracks in the ocean's hidden architecture. We'll also ask, what bizarre twists and paradoxes could arise from the combination of global warming and potentially diminishing ocean circulation? Will the meltdown of the Arctic paradoxically bring a new era of frost to nations that have always taken their milder winters for granted? And is it possible that the very loss of Arctic sea ice might, in a strange turn, help preserve a portion of our ocean highways? But hold on, do not imagine these theories come without dispute. Even as some computer simulations sound the alarm on a partial collapse of the Atlantic Meridional Overturning Circulation within the coming century, other studies question how immediate this risk is. Certain models see no catastrophic evidence, while others predict a near shutdown of heat transport that might create profound climatic whiplash across large portions of the planet. Tucked between these poles of debate lies the harsh reality that scientists only recently started measuring these currents in any systematic manner. Modern observation programs, like Rapid MOCA and OSNAP, are giving us glimpses, but it's been merely about 2 decades. Is that enough time to draw sweeping conclusions about potential collapse? When the Kronprins Haakon first arrived in the western Greenland Sea, the polar night still ruled supreme, and the horizon was often veiled in eerie twilight. The ship plunged through thick ice floes, forging a path seldom traveled by research vessels in winter. Here, the warm ocean currents flowing north meet the drift ice traveling south. It's a dynamic boundary, the very line between water cradling Earth's future and the relentless might of Arctic chill. The scientists on board maneuvered their instruments, lowered rosettes into the sea, gathered temperature and salinity readings, and launched drones to observe how and where the ocean was losing heat into the polar atmosphere. The bigger the heat loss, the more precarious or resilient the Atlantic Meridional Overturning Circulation might become. Hint: if you're as enthralled by these epic voyages as I am, Don't forget to drop a friendly like to show your support for stories that bring us face to face with the wonders and challenges hidden beyond everyday headlines. It's not every day we get to stand on history's front line, and your enthusiasm helps us share these crucial explorations. So, what do we really know about the Atlantic Meridional overturning circulation? At its fundamental level, warm and salty surface waters travel toward northern latitudes, releasing their heat into the atmosphere, like a feverish transfer that buffs Europe's climate. After unloading so much heat, that denser water sinks, plunging to the ocean's depths, weaving steadily toward the southern latitudes as deep currents. This process carries significance not just for temperature moderation, but for the global carbon cycle. When water sinks, it hauls dissolved carbon dioxide into the far reaches of the ocean depths, effectively stashing it where it cannot easily return to the atmosphere. That means, ironically, that a robust overturning circulation can help store some of the greenhouse gases that might otherwise further accelerate warming. Yet, the meltdown scenario starts with Greenland's vast ice sheet. As more ice melts, more fresh water pours into the upper layers of the North Atlantic. This fresh water is less saline and therefore less dense, which can prevent the ocean from sinking in some critical spots. Though there's some comfort in the complexities, like the possibility that the newly exposed ocean surfaces along Greenland in winter might drive additional heat loss from the water to the air, helping keep some of the overturning processes strong. Nobody truly wins in a scenario where global warming and local freezing events clash unpredictably. Perhaps one of the most striking concerns is the notion that, should the Atlantic Meridional overturning circulation weaken drastically or tip toward collapse, it would not happen overnight, but over several decades, long enough to sow chaos in human planning, but short enough to feel terrifyingly sudden from a geological perspective. Some studies, examining clues from Earth's distant past, warn us that abrupt swings in these ocean currents likely played a role in ending or intensifying ice ages. But that was in epochs we can only study through ancient sediments and isotopes. Now, with humankind's industrial footprint accelerating changes in temperature and ice melt, the risk is that we are playing a high-stakes game with the climate's hidden architecture without fully grasping the consequences. What might happen if the system starts to falter? One possibility is that changes to ocean currents will reroute storm paths and alter rainfall patterns in the tropics, making certain agricultural regions more prone to shifting monsoon cycles, droughts, or storms. Meanwhile, countries in northern Europe that currently rely on nature's free heating system might experience plummeting temperatures during the winter months, driving massive lifestyle changes, heating costs, and even transformations in biodiversity. Some experts even speak of a near-complete shutdown that could plunge places like the United Kingdom or Norway into a deep freeze reminiscent of ages long past, all while equatorial and southern regions grapple with intensifying heat. We find ourselves torn between extremes. On the one side, the underlying physics and geological records reveal that abrupt changes in the North Atlantic have happened before. On the other, direct measurements of the Atlantic Meridional overturning circulation from the past 2 decades have yet to show a definite downward trend. The signals are drowned out in natural variability. That's where the gigantic efforts aboard the Kronprins Haakon and other research missions come in. By gathering data in winter, when the water is cold enough to sink in some areas, they hope to piece together how quickly the system can respond to freshening or warming. Already, there are hints. Some scientists suspect that these polar waters might be losing heat so rapidly that it helps maintain a portion of the ocean's overturning function. But are these pockets of resilience enough in the long run? As the Kronprins Haakon's team lowered their latest batch of sensors into the black waters, they braved howling winds and seas that were peppered with glimmering shards of newly formed ice. They retrieved water samples that showed subtle changes in temperature and salinity through hundreds of meters of depth. The data would need thorough analysis. But the immediate discoveries gave them, and hopefully us, a rare window into a realm only a handful of people ever witness firsthand in winter. The question they keep asking is, are we glimpsing the infancy of a new climate pattern, or simply the normal, albeit freezing face of the Arctic at this time of year? We might take solace in the notion that not everyone sees imminent collapse. Climate models, after all, can differ based on how they handle the complexities of ocean stratification, atmospheric feedbacks, and ice dynamics. Some emphasize that the meltdown scenario remains uncertain, suggesting the system might only slightly weaken or change in ways that do not produce cataclysmic winter chills in Europe. Yet others point to data from the subpolar North Atlantic, where sea surface temperatures have cooled while much of the global ocean has warmed, hinting that a diminishing input of tropical heat waves might already be in motion. Of course, there is no single culprit behind potential changes to these currents. The interplay of greenhouse gas emissions, polar amplifications, factors like local sea ice decline, and massive freshwater injections from melting glaciers weave a complex tapestry. Unscrambling these influences requires consistent, year-round measurements of the ocean's pulse. Hence the importance of missions like Rover, which the Kronprins Haakon's expedition is a part of. If their hunch is correct, the experiences in the western Greenland Sea might rewrite some of our assumptions, possibly suggesting that warming-induced sea ice retreat and exposure of the waters in winter actively fortify the sinking branch of the Atlantic Meridional overturning circulation. As contradictory as it sounds, increased heat exchange between the relatively warm ocean and the frigid air might trigger more sinking, keeping part of the conveyor robust. But how long can that equilibrium last in the face of continued warming trends, glacial melt, and colossal shifts in the Arctic's temperature profile? That is the million-dollar query, or perhaps the trillion-dollar question, when factoring in how many human activities pivot on stable climate systems. And if you find this puzzle as mesmerizing as it is unsettling, here's a second friendly reminder to subscribe to this channel so you never miss out on future deep dives into the planet's most pressing mysteries. Now, stepping back from the raw data, it's important to realize just how isolated these research locations are. Far from the hustle of daily life, hundreds of kilometers from the nearest settlement, scientists endure around-the-clock darkness or faint polar light for weeks, all in the name of deciphering a climatic code that could shape the destiny of millions. Quite often, their only companion is the inhospitable Arctic air, the rumble of ice cracking beneath the ship's hull, and the hum of specialized instruments plunging into black water. The very fact that so few winter measurements exist for these areas underscores how difficult it is to ascertain long-term trends. In the same breath, it amplifies how urgent it is to gather whatever data we can before the story grows too complicated to piece together. The scientists measure more than just temperature, salinity, and current velocity. They also track how carbon dioxide is drawn into the depths, how oxygen flows in intricate patterns that can sustain deep-sea life, and how smaller currents swirling around the main artery might create microclimates. From these tapestries of data, they hope to refine existing computer models. Ultimately, better models lead to sharper predictions, which in turn inform the choices nations make about climate policy, infrastructure, and future energy demands. One of the expedition's more sobering discussions revolves around how easily so many societies can overlook a threat that doesn't have an immediate, singular shock event. While hurricanes or wildfires can rattle headlines because they appear swiftly and leave devastation in their wake, a major shift in global ocean circulation can unfold more insidiously, over decades perhaps. That slow-burning nature doesn't make it any less daunting. By the time the big changes become undeniably felt by billions, it may be very tough, if not impossible, to reverse course. Observational records from Earth's geological past suggest that once certain tipping points are breached, the shift to a new system can be relentless. Critics, however, point out that tipping point speculation can overshadow more mundane but also critical aspects of climate response. For instance, how local communities should adapt to smaller annual shifts, or how nations can reduce pollution. Yet the ocean's interwoven nature requires that we consider large-scale transformations. Our planet runs on water, heat, and atmospheric interplay. The deeper we peer into how these currents function, the more we understand that what happens in the Greenland Sea can ripple through the rainforests of the Amazon, or that a temperature flinch in the subpolar North Atlantic might reverberate in monsoon patterns half a world away. In the end, the Kronprins Haakon can only stay at sea for so long. The team concludes their winter expedition, hauling up moorings, retrieving memory cards brimming with data on temperature, salinity, and current speed. Snapshots of a dynamic dance that, for all its enormity, remains delicately balanced. With each new mission, they refine the broader picture, a planet on the edge of change, still harboring unknowns that even the brightest minds might only partially grasp. Will the Atlantic Meridional overturning circulation hold steady enough to keep northern winters temperate and southern climates stable? Or are we perched on the edge of a shift that, once fully realized, could cascade across hemispheres? The truth lies in the synergy of advanced modeling, historical patterns, and every data point that dedicated oceanographers reel in from these icy waters. In essence, we are writing a narrative that could echo through coming generations. Whether that narrative becomes a testament to early warnings heeded or an epic lament of opportunities missed is still up to our collective actions and the ocean's own hidden rules. Ultimately, in a world where gloom and doom often overshadow progress, stories of polar expeditions and dedicated science teams pressing forward through extreme conditions remind us of what is possible when determination meets curiosity. The fact that no single mission or discovery can solve this puzzle underscores both our vulnerability and our ability to keep searching, testing, and learning. As we drift away from the Greenland Sea and back to calmer latitudes, let us remember that a single belt of ocean currents may shape the weather, climate, and survival prospects of untold generations. Rarely has one phenomenon been so profoundly global in its impact. So, stay curious, stay engaged, and keep an eye on the horizon, literal and metaphorical. These currents might be invisible beneath the surface, but their force is immeasurable. And whether they continue flowing or begin to stagger, one fact stands clear. The world will never look the same once we become aware of just how pivotal this underwater powerhouse truly is.